Welcome to the panel Commodore, the 8-Bit Years. My name is Earl Evans, and I'm pleased to be sitting with this distinguished panel of Commodore alumni. I think this afternoon is going to be a lot of fun. I'm very happy that we have the chance to chat with these gentlemen. Let me introduce them. First, all the way over to my left, we have Bill Hurd. He led the team that produced the Commodore 128 after having worked on finishing the engineering and rollout of the Commodore TED series of computers. Right next to Bill, we have Benny Pruden. I was just trying to find you on my paper here. Who worked on various projects within Commodore, including the PET, CBM, and Commodore 64, and also spent time in the advanced super secret R&D group.
Oh.
To the right of Benny is Leonard Trammell. Also with Commodore since the calculator days, Leonard worked in quality assurance, design, and software for the Commodore PET, and is one of 3 sons of Jack Trammell, Commodore's founder. And finally, directly to my left is Yash Terakura, who was with Commodore in Japan and worked in engineering on calculators, the VIC-20, and the Commodore 64. Gentlemen, welcome.
Oh, thank you.
I did want
We
to...
seem to be missing somebody, Earl.
Yes, I did want to mention, before we actually get started in earnest, we're sorry that we don't have Chuck Peddle with us tonight. Originally intended to be part of the panel. Chuck is, of course, the father of the 6502 microprocessor and the Commodore PET, and we were hoping to hear some of his insights, but unfortunately Chuck wasn't able to be here.
No.
So
He might be downstairs, so if anybody sees him...
if you see Chuck,
he might be looking for
point him upstairs.
Up, Chuck.
We love puns. We really do.
Yeah, if he sits there.
So, of course, this is the 40th anniversary of the Commodore PET. It was the first in a long and distinguished line of computers from Commodore, 8-bit systems. We have a poster here that graphically shows just the sheer number of 8-bit systems and peripherals that Commodore introduced in the line, all the way from the original PET 2001 to the penultimate 8-bit machine, the Commodore 128. So with our panel, we'll chat with them about their role at Commodore and the activities they were involved with respect to these computers and the associated hardware, peripherals, software, documentation, and that kind of thing. Since we're talking about 8-bit systems this afternoon, I put together a list of the 8-bit systems that Commodore released from 1975 onward, and we'll go through these one at a time, perhaps in the order of when they came out, and we'll talk about the fate of some of these machines. Also, how were they engineered? What was the intended purpose, the original brainchild for the machines, that kind of thing. So with no further ado, shall we get started?
Well, what I was going to suggest is, since Chuck isn't here, I could relate what a little bit I've heard him talk about, but the genesis of the 6502 and MOS technologies. Leonard, do you know some of that time frame also, or?
A little bit.
Yeah.
Yeah.
So if you've ever heard Chuck talk, he talks about why come up with the 6502, a microprocessor. And when he tells it, he talks about working at Motorola where they have these big $13,000 boards and he can do it in a chip. And the people at Motorola didn't like that. They're stealing money from the big group, and they sent him a cease and desist letter to stop making this microprocessor. And Chuck took that as a legal release of the IP. He took the 6502 and left, 6501 or something at the time, right?
Yeah.
Something like that. And of course, a legal battle ensued, but as Chuck said, cracked me up, he's like, I've been kicked out of better places than Motorola. So there was just a lot of animosity with those guys. But I never met Chuck in the old days, but you could tell, like I used to say, there was still a cigar going in the ashtray and the chair was still warm. It just felt like that at MOS when we got there. And we called them the Gang of Five. But I don't know if that's really, if there was actually 5 engineers and it was the gang of, but it was Bill Mensch, Winterbull, Chuck. Who else was part of the 6502?
If I had known you were going to
Anybody
ask me
knows,
that
shout it out.
question, I would have looked it up.
Yeah.
Yeah, Charlie Winterbull and Bill Mensch are the two names that
Yeah,
come to mind
yeah.
besides Chuck.
6502.org has their names. So, it's but the and then they were founders or owned MOS or had bought MOS, but they were losing money, is my understanding, when Jack Tramiel came along.
Yeah, so Commodore got involved with MOS Technologies as and the 6502 completely by accident. The initial reason that Commodore was interested in MOS technology was because Texas Instrument was making it basically impossible to make calculators, which is what Commodore was doing. So they needed another supplier of calculator chips. So the easiest way to make sure that you had a supply of calculator chips was to buy a company that made them. MOS Technology was conveniently at the time in the process of going broke. So it was easy to buy. And when Commodore acquired MOS Technology, there were many engineers and people working on various projects, one of which was the designer of the 6502, Chuck Peddle, who was intent on building personal computers. And when I met Chuck, we had a very long conversation, mostly about science fiction. He was absolutely enamored with a story called The Door into Summer by Robert Heinlein, which had lots and lots of embedded electronics and intelligence and many things. He wanted to live in that world. So since no one else was making it happen, he decided he'd do it. So to make lots of computers involved in everything, you need to have people familiar and comfortable with computers. So you needed to have personal computers. And to do that, you needed an inexpensive microprocessor. Right. And that's why he designed the 6502.
And then when I heard Chuck say, after that, he said, whoa, it wasn't the processor, it was the I.O. chips that went with it. Because to make a terminal, right, you can't just have a thing. You have to have a thing that scans the keyboard and do everything. So when I've talked with him, it's not 6502 as much as in the
and the
parts.
Other. So if you, somewhere back there, there's a Kim 1, which is sort of the first. Oh, not only back there, but right here. So the Kim 1 was basically the first machine that had all of the electronics necessary to make a complete computer system on a board. Spectacular I.O. capabilities with a 16-button keyboard, 7 segments, so lots of I.O. Display. The processor, 2 I.O. chips with built-in ROM, and of course timers and all the I.O. you want. One of the more amazing things that was done with this machine is someone actually wrote a chess program that would run in 1K of 8-bit RAM. Which
You mean 1 meg, right? Or
no, I mean 1K.
terabyte?
1 kilobyte. Well, 1,024 bytes of memory. But actually, in order for it to work, he had to use some of the data storage ability. They're mostly gates in the I.O. chips because he just had to store extra numbers. So things, if he didn't need it to do I.O., he used it to store stuff. It was tight.
And you all have probably seen more Kims than we have, but when Chuck was asked about the design of the Kim 1, was that him and stuff, the one answer I heard was, well, it was a calculator company. You figure out the look and the feel of the calculator pad. So, and what year was that made?
I think that came out in 75,
Oh.
74, 75. There may be a copyright date on there. I don't know if we can read it with our old eyes.
Rev A.
It's Rev A, so that's early. Yeah, I think it was 75.
I think you're about right.
Yeah. So my first job at Commodore was working as a process engineer for Commodore's liquid crystal manufacturing facility. The first time I just wasn't working for the summer, and we were talking to an external supplier. They were going to sell us this really fancy computer-controlled machine for using a diamond to cut all the glass. And the guy said in very hushed tones, it uses a Kim 1 as its main electronics, and we were making them in the other room. So I pulled open my desk drawer and said, oh, you mean one of these? And that was fun.
Yeah, think about an entire computer on a board.
Yep.
That's
Yeah, that's the first machine I ever programmed.
and now I think all of us worked in the MOS building, didn't we? Yeah. Which if the MOS building was like a crazy place to work. It's the show with E.T., the Atari show where the guy's walking up and seeing the Atari building as for his first time as an employee. I remember doing that at the MOS building, going, oh, looking up at. I made the mistake of parking on the wrong side where they had the water jets going to aerate the ground because we had polluted the ground.
As semiconductor companies tend to do.
So when I came out from my first day of working at MOS, my car was covered with a sticky substance. And on top of that, I had parked under a tree, so the leaves were stuck to me. I mean, I couldn't get my windshield wipers to work or anything. And they're like, oh, no, don't park on that side of the building. So were you there when we had the explosion downstairs? Maybe not. We won't talk about that. But it was a great place to work. There was 3 of us in offices. They were painted psychotic blue, and you just knew you were in a good place, right? I mean, there's a chip fab below you. How could you not succeed, right? How could you not make computers? So that was and I wish Chuck were here, because I always love hearing more about the genesis of processors and his plant and his process and the whole NMOS thing to begin with. So.
I recall when, there I am. I recall Chuck telling the story of the 6502 that when he was with Motorola, he was running around to all these various engineering companies, and they were saying, yes, we like the Motorola chip that you're showing us, but we don't like the price of this processor. At this price point, we can't embed that into our product. We would like something a lot cheaper that we could embed into our product. And that was part of the genesis of wanting to go to MOS technology and do their own chip, because they knew that they actually could do the chip at that price.
Everybody's heard the chip about selling them out of the suite? Everybody hear that story? The story from Chuck is when they went to the show, and I don't remember the name of the show.
West Coast Computer Fair.
Oh, the WestCon,
yeah.
wasn't it?
Yeah.
Yes.
And they wanted to sell 6502s right there. They had the barrel of 60, and they were told you couldn't sell them on the floor. So they went and they got a suite, and they started telling people about it. And the way Chuck tells it, it's like at one point when the shuttle would show up, they're like, "Is this the shuttle to the suite where the 6502 or where the MOS is?" And he had his wife taking the checks or the money, and they had a barrel of O2s, but they had the real ones, the working ones, kind of stashed away. And one of the people he sold his first 6502 that day to was Steve Jobs.
Probably was.
He said Steve, but maybe.
Other Steve.
Now he did go say he went and helped Woz get it working. So he did make the distinction between the Steves when he talked. So.
And I think one of the reasons that they were able to make the 6502 so cheap was because their fabrication process didn't destroy what actually created the chips, the mask. They figured out a way to make the 6502, but without destroying the template for making the 6502 in the process of making the 6502.
Yeah, so they didn't have to generate masks
Right.
every run. So that was something that MOS did. But the design of the 6502, and there's a wonderful transistor level recreation of the 6502 back there.
The monster.
The Monster 6502. The detail that was that they went through to make this machine as small as possible, because it was all the smaller the chip, the more you could fit on a wafer, and that was the fixed price.
Now later, I will say that we ran the ion implanter at such a high rate when I was there that we were breaking that thing every 3 days. So we were saving the masks, but we were burning up the ion implanter.
Ah,
You know, that actually pushes the into the chip.
well, so moving on, we talked about the Kim 1 a little bit, but I had a couple of follow-up questions on that. It was intended as a board to teach people how to use the 6502, but people bought them to use as a computer in their own right because people really wanted computers back then, and they didn't want to have to build one from scratch. They didn't want a kit. Does anyone know how many Kim 1s were ultimately sold? Because I understand that it actually contributed pretty well to Commodore's cash flow at one point.
Yeah, no idea.
There's a lot. Hundreds, maybe.
Sam?
So we'll move on. The next computer in the line, the PET 2001, probably one of the iconic faces of early personal computing. It was one of 3 computers that came out in 1977 that for the first time you could go to the store, you could buy a computer, bring it home, plug it in, and just have it work. There's the PET 2001, the TRS-80, and the Apple II. Came out in 77. So the PET was really Chuck's dream. This was his baby, was to produce a computer based around the 6502 chip. So when I look at it, I think, wow, that's a metal case. And as I understand it, the decision to use a sheet metal case didn't set very well with some of the folks at the time, but that Jack Tramiel wanted to use the sheet metal case because Commodore owned an office furniture company that could actually produce that. Do you know if that story is correct?
That is correct. Yeah, so these cases were made just outside of Toronto, Canada, in a manufacturing facility that made desks and filing cabinets and computer housings.
So the prototypes that I saw for the PET were a little bit more rounded, a little bit more pretty.
Yeah, there was one. I understand there may have been another, a hand-carved wooden prototype PET, which we were discussing earlier.
Trying to
figure out who has it or who threw it away, as if anyone would do that to a priceless historical
It's
artifact.
either that or move it to Westchester.
Yeah. So we've lost track of that, but yeah, you can still find the occasional picture of that machine. It looks actually a lot in the rounded shape. One of the machines up there, the B500, is reminiscent of the original wooden PET.
So I really had wanted to ask Chuck this, but I also want to pose it to the whole panel. Now, with the benefit of retrospect, this kind of angular look on the Commodore PET, the metal look, do you think it's past there? How do you think that look is held up over time? Do you like it? Or would you rather have seen the rounded PET that was in the
It's
original
iconic.
prototypes?
I think of a PET because it's a PET. So and I will add, they forced us to use the Commodore furniture ourselves also. In the long drawer. Oh, yeah.
So I was at a rather bizarre science talk a couple of years ago. The question was, do we live in a computer simulation? And the lecturer just had a bunch of different visual cues for things. The symbol he used for the general just computing device was one of these. So that angular shape has made it into the mainstream consciousness, not necessarily as a computer, but as an abstract computing device.
And I've seen it in TV shows and in movies.
And in movies.
And the PET has had a lot of media exposure, and I think due in no small part to its very unique style.
Probably. Yeah.
I have an anecdote. I'm going to try and keep my own personal anecdotes to a minimum, but I do have a little story about the Chiclet keyboard on the PET. The Chiclet keyboard is actually how I came to be a Commodore fan for the last few decades. We had 3 computers in our school computer lab. One was a teletype where you could dial the mainframe and talk to the big iron downtown. The other was a TRS-80 Model 1. And the third was this Commodore PET 2001 with a Chiclet keyboard. And nobody wanted to use this computer because it had the funny keyboard. So I thought, I'm hungry for computer time. I don't mind if I have to use a smaller keyboard to get it. And what I found inside was a machine that had a lot of heart. It had the graphical characters, it had a good basic, and it had a tape deck that never, ever once ate my programs. Unlike the Apple II and the TRS-80 and some of the others that destroyed some of my hard work over time, this tape deck never failed. Now, the rumor has it that it was chuck pedal and an oscilloscope and a bunch of time to make that tape deck so reliable. Does anybody have more information on that?
That's absolutely true. I'm trying to remember how long it took, but Chuck, a tape deck and an oscilloscope, locked by himself into a room for a long time, and lots of very tightly hand-optimized assembly software. We wound up testing the machine by taking a tape deck and taking one of the capstans that runs the tape feed and drilling the hole off-center so that it had this enormous wobble to the tape speed, and then would take tapes that were recorded on one machine and played back on another. And if it could survive that, it would work with anything. The reliability of the thing was amazing. And I remember asking Chuck a couple of years later how he got it so reliable. And he said, I have no idea.
What we kind of uncover in the movie, The Commodore Wars, that we did with Junk Food, was I got the thought that maybe because the drive was so good that we weren't as quick to go to floppy as some of the competition was. And had the tape drive not worked as well, maybe there would have been more incentive, but in our minds, it worked well.
There's always a downside to everything.
Yeah. Mm-hmm. Yeah, it's too good. Anybody?
The question was, is there a story behind why the original PET had a Chiclet keyboard rather than a full-stroke, standard-size keyboard?
Well, Chuck insisted that everything fit in one thing, and there's just not room. It's really that simple. So when we had the external cassette drive, there was room for a full-size keyboard, and the next model had one. Also, it's a lot cheaper to make something like that.
And I think, if I recall right, Jack may have even challenged Chuck to say, how do you know, I mean, you're inventing something brand new that hasn't really existed yet. How do you know people are going to want a full-size keyboard for the computer?
Well,
Maybe
how do you
they
know
don't-
people are going to want the computer at all?
Period. It's true.
Yeah, that was a bigger question. First, you have to convince people that you want a computer. Then you worry about details like what size keyboard it has.
I guess it turned out from the pre-orders that people did indeed.
Yes, the pre-orders indicated that there was definitely a need out or a desire out there, a
So-
ready-made market.
A couple of other
And I can speak to
questions.
that, actually. I remember the NTC 77 when they actually did start selling this computer, and I bought the very first one. And I remember this form I filled out, and I wrote the check and sent it into the mail, and it was $795, I think, for an 8K unit.
8K.
For the 8K unit. And it was going to be 90 days until I could get the unit back. And that's how it worked. That, from what I understand, they didn't have the money to buy the parts for those machines at that time, and that's what the 90 days was all about, was to buy the parts and to build the production. But yeah, I was.
Yeah, there were not a lot of. There was not a large inventory of machines from which you could pluck yours to deliver it.
So sure enough, 90 days to the day, a box shows up with my PET inside.
I'm
Changed
glad,
my life forever.
I'm glad we made the deadline.
Absolutely.
Did you not wind up taking the pet and making a cash register?
Oh, that was later on. Later on.
That was later?
Later on. After I'd taken-
I find that interesting because the 6502 was originally designed to be an embedded processor in things like copiers and games and maybe cash registers, but you wound up taking the computer and actually making it a cash register. And
So after I had learned how to program the computer, and then of course it broke, the RAM fell out of it. I fixed that one time, and then I joined with some friends and made a Commodore dealership. And the person who let us run this dealership was in the back of a cash register store, and people came in asking for a real point of sale machine that could do what we see every day, where you order something and it prints in the bar and prints in the kitchen and so on and so forth. And we just put a cash drawer on it and changed out the keyboard to be a cash register keyboard and glued a printer on top. And we sold more of these, and we became the largest dealership within a couple of months. The Commodore bought us out and moved us to Dallas. And that's where that came from.
You're from, so we had the Commodore Texas group.
Yes, that's right. They formed the Commodore Texas group for 1 year to build the cash register.
And you had brought some crazy stories with you. I remember you had a crazy driver that when you went to lunch, you weren't all allowed to be in the same car.
Yeah, that was my boss that had actually moved from the original programming shop that I was at before to start the dealership. And he was a little bit crazy. He had this old Mazda car, and he used to drive it sideways into the parking lot, and he'd take us to lunch. And we came into the parking lot sideways one time, and we almost sideswiped our boss. And it became a deal that no one can go to lunch in Ned's car anymore together.
The entire...
The whole crew could not ride with him, none of them at all.
Well, the other story I remember is you were saying they were so wired for sound back then, we all knew hex code cold, right?
Right.
And you guys went to lunch one day, and the guy tries to make change for $2.55. He thought
Looking down at the LED machine, it was a 0FF. And he was trying to pay $2.55. It's like, sorry, that one's off. It's not. Yeah.
he automatically and
Automatically.
Ryan would multiply hex in his head and stuff.
You're on this register, okay?
one of the things that made the pet so iconic, and actually all of the progeny, was the Petsky character set. So you worked on some of those glyphs, didn't you, Leonard? Didn't you work on some of Petsky?
Yeah, the character set that isn't obvious, the uppercase letters and numbers. That was my job. Chuck said you have 256 characters. Well, actually 128, because one bit just said invert them all. So you have 128 characters. There's some number used for the letters and numbers and punctuation. And you have to have hearts, spades, clubs, and diamonds, because I want to play blackjack. Figure out what to do with the rest. So many, many iterations of graph paper later, we got that.
So did you have, I heard that you had like another goal, making sure you could draw things or something, or what?
Yeah, so there were a few things that I tried to do with the character set. So one of the programs I wrote for the PET was the Lunar Lander game. So we had to be able to make a decent lunar lander. And when I got something that looked like a passable Star Trek Enterprise, I think, okay, this is good.
Good job.
Because if it can do an Enterprise, it can do anything.
Right. You got angles.
We had the angles. And, well, anyway.
So in one of these, alternate realities are big on TV and movies right now. So here's an alternate reality that I guess might have happened. The Commodore PET actually might have been sold through Radio Shack, from what I read. But it turned out...
Yeah, there were discussions.
But I guess it didn't turn out that way. How do you think things might have been different if the PET would have been distributed through Radio Shack? Is any speculation on that?
I know the answer that I think I heard Jack Tramiel say at the anniversary, but I'm looking at Leonard first to see if he wants to. So the story I heard is he went into the Radio Shack discussion, and but he really wanted them to sell calculators also. If you take the PET, I want you to sell my line, and I might have said the word exclusive, but I'm going off old memory. And the way it was said was that discussion, the conference with Radio Shack was over by noon and it never got revisited. So it was a very narrow window when that happened, is my understanding. And it dealt around, he wanted to keep the calculator channel, he wanted it through Radio Shack. Does that sound plausible?
Yeah, that sounds about right.
Okay.
And just one more question on the PET before we move on. Yash, I'm curious, was the PET 2001 sold in Japan? Was that available in Japan?
Yeah, not too many, but I would say few thousands. Not too many, not as many as the United States, but it was pretty expensive in Japan when they started sell. So it was not much, and not many programs for Japanese. But at least we did change the characters to Japanese characters.
There were some kana?
Some
characters?
space and hearts and everything. So katakana we put it in, and that was one of the first computer which could print out the character, Japanese characters. So
At least the katakana.
yeah.
So moving on to 1979, some upgraded PETs come out. I don't know if we have any of them up there, but you've got the 3000 series.
So up on there, they've got the 4000 series and the 8000 series. Mm-hmm. Yeah.
So those, would you say those were just incremental improvements to the Commodore
Oh,
PET?
absolutely. Yeah.
Very similar in approach and the bigger keyboard. So I guess people really did want the bigger keyboard.
The bigger keyboard, the 8000 series had 80 columns of graphics, so higher resolution, more standard chips being used. So there was all of the video circuitry in this beast is all done in individual pieces of TTL. There was actually a video processor on the 8000 series. So that whole bit was different.
And would software from the 2001 run on those
Yeah.
later PETs?
And it had 32K of memory.
So those
Yeah,
computers were...
so there's I think the two
4032.
machines that are up there are the 4016, which had 16K of memory, and the 8032, which you can guess had,
32K of memory.
yeah,
Oh boy. Wow.
extremely obscure model numbers.
So what do you recall about those machines? Who engineered those? Who brought them to market? Was it Chuck again, or was it a
So
different team?
at that time, I was off in New York getting a PhD in astrophysics. So I had no connection to the company at all at the time. So if any of you good gentlemen know anything about this, please chime in. We need Chuck. Chuck, where are you?
So was there any discussion of color at this point, or was it being felt that black and white was good enough?
Wasn't there.
Okay.
No idea.
We try and answer that in the video, but I was just asking a leading question.
Yeah.
So the next thing to come after those incrementally improved PETs was the VIC-20 in 1980. And this was a whole different beast altogether. So Yash, first question I have is for you. The VIC-20 was introduced first in Japan, from what I understand, as the VIC-1001.
1,000, yeah, that's right, yeah.
And how did that come about? How did Japanese consumers react to that computer?
Well, when Jack started to think about the different computer other than a PET, he came up with this big idea, and actually the big was designed by Chuck's group also, with Bill Sila and other people. And I was called in from Japan, and Jack said he wants to build that computer as a product, not a just prototype. So I had a prototype, and then he told me to take it back to Japan and make a computer out of it. So that's what I did. And at that same time, Jack said, I want to be a #1 computer guy in the world.
Talk louder,
Yeah, to do that is to sell the computer in Japan and be a #1 in Japan, then you'll be a #1 in the world. That's what Jack said. So he told me to just make one for Japan. Don't worry about other world, but make it for Japan. So I designed it, and keyboard and everything Japanese way.
And what sort of things did that design entail? Were you working on the chip design? Were you working on the industrial design of how the computer looked?
The chip itself was 6502, and the big chip and the SID chips, and was done by the MOS already anyway. And out of that, we have to just make sure that we are able to buy the parts in Japan only, not relying on the other source like United States or China or Korea or whatever. So we did buy everything in Japan, including a keyboard, and we did design the housings in Japan, and we did plastic molding in Japan also. So pretty much everything was made in Japan.
Yash was one of those then that, Commodore was who they were because we had such a strong Japanese, design house interest, connection to the suppliers and everything. And Yash was one of those guys going back and forth, keeping Westchester and Tokyo talking. I mean, back then we had telex
that time
machines.
Was Santa Clara, not Westchester.
here?
Not Westchester, Santa Clara.
Okay.
Yeah.
Okay, but yeah,
Yeah,
in my mind,
we-
the West,
U.S. and Japan.
U.S. and Tokyo, yeah.
So the VIC-20, revolutionary again, color, using a chip that I guess MOS technology already had, and that they were trying to sell, but it wasn't selling.
No, the chip was designed by one of the chip designers at the place, and was here's a great thing, and they made a little prototype with they could do color, and said, all right. My dad was not a computer person, and he had them bring it to a consumer electronics show in Chicago to show it to some of the marketing people and salespeople, and he brought me from New York to come and take a look. And we looked at this little tiny machine. It was actually the case it was in was significantly smaller than the VIC case that wound up coming out. And it ran through demos and did all sorts of neat whiz-bang stuff. And we looked at what it could do and the price they said they could produce it at. And everyone went, wow, this is going to be great. And then Yash turned it into a real machine.
Yeah,
And
that's the
away it
urban
went.
legend that I heard was they showed him the demo thing that was made for the chip, and Jack goes, good, sell it. And I go, the chip? No, the demo.
Yeah, so the machine was designed to showcase what the VIC chip could do. In fact, the name VIC comes from video interface chip. That was the name of the chip. And if you want to design a machine to sell the chip, let's call the machine the same name as the chip. So VIC does not stand for video interface computer. It's video interface chip with a computer built around it.
Now, there's an urban legend about the name Vic and not using it in Germany.
That is not an urban legend. That is just translation. Yeah, Vic is not a polite thing to say in German company.
My understanding, again, the days from Telex is get a Telex says, please do not call it the VIC-20. It is not a very nice thing to say, as Leonard just said.
It's the Volkscomputer,
Yes.
the VC.
And we ignored the Telex because we're Americans. And then we get another one that says, really, no, don't call it the VIC-20. And then finally we get another one that has a more gross term for no, it means copulate. And we ignored that one too. And so what happens, they had stickers, Ray, and they just put their own VC-20 stickers on our things when we got to the show because they knew we were ignoring them.
And it had a different brand in Japan also, the VIC 1001. Why was it called the 1001?
Well, we had a big, PET 2001, and we figured it is son of the 2001, so just make it 1001. So very simple, and there was no, real thinking or anything involved. It just, I think it was Vic Tokai. You know, it was a name. Tokai.
I don't remember who came up with the number.
There was a general manager in Japan was Tokai-san, and Tokai-san just came up. So let's go into 1001. So that was it.
Perfect. One of the engineering questions that gets asked a lot in the modern Commodore community on both the VIC-20 and the Commodore 64 is why did it have such a slow serial connection to the disk drives? The PET and some of its follow-on models had the fast IEEE interface to the disk drive, moved quickly. People in the Atari and the Radio Shack realm joke with us Commodore people that we're still waiting for our programs to load in 2017. So how did the slow serial bus happen?
It was the number of the I/O ports, I believe, on the VIC-20 and the cost of adding additional I/O ports. The serial port on the VIC-20 and the Commodore 64, the commands were actually based in the IEEE 48 protocol, but they actually used the clock serial interface to communicate the 8-bit bus across. And unfortunately, especially in the Commodore 64, one of my first functions was to build the 1541 drive for the Commodore 64, which is to slow down the serial bus interface. Because the Commodore 64 has in a mode where it would do the DMA for the processor and the graphics every other cycle, but then there was a 40 microsecond period where it took both sides of the cycle and the processor would stop. So if you're doing a clock serial interface through software, you would have to wait at least 40 microseconds before you could move the clock again. And in the VIC-20, it was only 23 microseconds. So we had to build a 1541 that was that much slower. That's why it turned out to be quite so slow. I did try to do a hardware interface for that at one time, but it missed the cycle for the Commodore 64 to be produced. The board was already laid out. It was too late, even though I proved a prototype for it, but it just didn't make it in time.
Now, the background that I've heard, and I've heard from chip designers, and is the hardware serial shift register that you would have used for the hardware to speed it up had a problem in that one of the nodes would float. And so when you switched from an input to an output, it would thump, it would charge the bus and basically lock up the peripherals depending on how they were listening.
Okay.
So the 65026 had to be fixed first. So what Bob Russell did then was left 2 traces to the I/O pins, but ran 2 traces to the 6522 pins so that when they started to work, we could jump to it quickly. And Commodore Japan saw those. Remember, we don't have Gerbers and all that. It's all, photograph. And they thought it was a mistake, and they painted out as 2 traces because it's shorting 2 outputs together in their mind. And
it was wire OR together.
Yeah,
yes.
and we lost a chance to switch back over to the hardware once the 26 was done.
Oh, beautiful.
Yep. I got the charge coupling from Angelina, so I trust that one.
Nice.
So the slow disk drive notwithstanding, I think was the VIC-20 in its various iterations the first computer to sell over 1 million units? I thought I'd heard something like that.
They would have had to.
It was certainly the first Commodore computer to sell over a million units. I think it was probably the first to do that.
So it was a pretty big success by the...
Yeah, it sold well.
Mm-hmm. And following on in 1982, the Commodore 64, the
That
big
sold better.
kahuna. That, I wonder, I'll throw this out first. It's not on the sheet. Sorry, I'm going off script. There are varying reports about how many Commodore 64s were sold, and they vary wildly. I mean, we're talking between 16 million and 30 million are the estimates. Why do you think the range is so big in terms of guessing how many Commodore
Marketing people.
Marketing people lie.
I didn't say that last word.
I did. Actually, they're in the Guinness Book of World Records at 27 million, right? So everybody see that?
I think that's right.
Yeah.
So that's the number, and we're sticking
That's
with
the number I use, is 27 million.
Perfect.
And that's a single selling model of computer. So PCs don't count because nobody did 27 million of any one thing. It wasn't until like the iPad 2 came along that something computer-like sold a single model that many. And some of that is just the fact that Commodore didn't muddle with the C64. I mean, we had it where we had to make it better. We had Flickr. You told me about the Tiger team to fix that and stuff. And I saw where they went in and dinked with the power supply to try and get the crawling stuff, but it was still a Commodore 64. It still did exactly the same thing in the exact same case.
Same chips.
And yeah, so you got one, you didn't have to worry about if it's compatible or not, other than being broken, with the other ones. And that was great stick-to-itiveness of the Commodore mentality, and maybe that's Jack Tramiel behind all that.
It reminds me a little bit of platform home video computer or systems today, like a PlayStation or an Xbox or something like that, where a software creator has a known quantity that they're writing for, as opposed to writing for a computer that could be in any of 25 different configurations and you don't know what you're going to encounter. With a Commodore 64, you knew what you were going to get. And Commodore 64 had a big software base, didn't it? There was
Enormous numbers of entire software, pieces of the software industry started on
a whole
that.
ecosystem.
So lots and lots of companies came into existence because of writing software for the Commodore 64.
So, Yash, you did some work on the Commodore 64 as well in engineering, right? Is it similar to the work that you did with the VIC-20?
Yeah, it's a little bit different. After we finished VIC-20, then Jack told me to move to the United States and start developing next stage of VIC-20. And that was this Commodore 64. And we did make prototypes. Then he still wanted to make the computers in Japan. So I took the prototype, went back to Japan, and created a group in Japan that time. Because the VIC-20, we created a team in Japan, also in US. But this time we just did everything in Japan. And since I moved out of Japan and moved to the Pennsylvania, I had hired another guy taking my place in Japan, and he's the one, Okubo-san. You met Okubo-san.
Who?
Okubo.
Oh, yes.
Yeah. He's the
Okubo-san.
one did all the layout of the PCB and the housings and all the modifications to be a 64. Yeah.
And at what point in all this were you the head of engineering? So you were head of engineering of one of the Commodore divisions at one point, is that right? Yeah.
Yeah.
Was that during the 64 time, or?
Yeah, during the 64, yeah.
I see.
So I had a question, Yash, and I mentioned it. In the C64, the final models, the 9-volt supply was rectified and turned into a second 5-volt. Was that an add-on later? And it looks like they were trying to isolate the 5 volts to isolate the video noise and to give the VIC a better. Is that any of that familiar?
Yeah, that's pretty much Okubo, and we worked on it along with JVC. And so we can really put 40 characters on a regular TV screen. That's what we did,
Right.
yeah.
Because when they started, my understanding is the Commodore 64 had some, it wasn't all locked together, and so you would get crawling dots because the way the beat frequencies of the clock of the 6502 and the color clock of the VIC. And so first they had to isolate those power supplies and everything, and then they phase locked it so that it now stopped moving in relation to it. But then you told me the Flickr story from the Tiger team. Do you remember the Flickr story?
I do. There was a character generator ROM in the 64 that they did an EEPROM originally, and they built a hard ROM for it. Right before we started building the Commodore 64, they had hard ROMs that were built, and there was just all sorts of snowy garbage all over the place, just snow everywhere. And the problem really was the ROMs, the hard-coded ROMs, decoded much faster. So whenever the enable line occurred, there was a precharge that happened before that, and the precharge would be gone away. So basically, the character generator was too fast. And of course, we threw a capacitor on it and started shipping them in the millions the next week.
So, and then the other one I remember you talking about is it used to, if you remember that Commodore blue with the light blue on the dark, it would flicker. You'd see these light blue flickers everywhere. So what they did is on the cells, they would turn it so that a cell that had that, they would make it so it's still flickering, but now it's flickering dark blue on dark blue instead of light blue on dark blue. So it's still flickering as much, you just didn't see it on the empty
A little
cells.
bit still, yeah.
Yeah. If you looked, you knew where, but yeah.
Software fixes the hardware, yeah.
And somebody
Sort
got
of. Not
a
really.
lot of money for coming up that suggestion, or the team got lots of kudos for thinking of things like that.
Are there other fire drill kind of stories that you can think about during the Commodore 64 engineering and rollout that, I mean, when you're talking about these kind of volumes, it's like if you discover something, you got to fix it pretty quick.
Color. The color fire drill, of course.
Well, it didn't work. The Commodore 64 doesn't work on paper. The DRAM timings don't work if you take the minimum and maximums and the way the RAS and CAS can move. And it's because even coming from the clock, we know a frequency, but we don't know where the edges are on both clocks, and we try to use the falling edges and the rising edges, and you could get variations. Bottom line, it freaked me out when I started the 128 because I'm like, I knew it didn't work, and now I really know it doesn't work. So one of the things that was going on was in production they were being reactive, and they would actually start soldering capacitors on very important control signals called RAS and CAS, which goes to all the DRAMs. And you can't do that. It slows it down. It becomes a ramp, and now things are going to go metastable and stuff. But they could get it to pass the test cartridge by doing that. So we had to kind of battle with, well, they're trying to get them out the door, but this thing actually has these constraints where in timing we can always worst case fail. And I'm talking about by the time you heat it up or the variations in the power supply and stuff. So back then, if a C64 only went about 20 or 30 minutes before rebooting, that's kind of normal in my mind, right? Please don't get mad. But, it got better. We went to 150 millisecond RAMs, and we also sued Micron, to try and get through the problem.
Yeah, so most of the 27 million would work for longer than 15 minutes.
They appear to work.
Yeah.
Unless you're an engineer, it'll drive you. If your name's on the timing, it doesn't work. But yeah, it worked good enough that we sold 27 million, and you could play a game, and you could have a good time. A guy told me he was running his business on this Commodore 64. I said, back away quickly.
So one of the things that I think helped the VIC-20 and also the Commodore 64 was having an excellent programmer's reference guide, including, all the way up to even having a schematic of the computer. Did any of you have a chance to work on that, or do you know who did, or how those books came about? Because they seem like they were very helpful for the software community. Yeah. They're still used today with the...
I'm trying to remember who was in charge of doing that. I wrote at least one demo program for the Commodore 64 Programmer's Reference Guide. Let me see if I remember what that thing did. There's a demo program for how to make a sprite move around. And there's data statements that have a little drawing of a balloon. And it moves that. I wrote that.
Excellent. And the lunar lander for the
Commodore PET,
For the PET. Mm-hmm.
And as you said, there was the spec sheets for the processor in there. There was timing diagrams, and there was the schematics. And I didn't.
Well, actually, that was me. I did that in Japan.
See how long he waits to admit something.
When we started to sell back in Japan, I said, well, nobody ever did that. Well, but why don't we just release everything? Like Apple was hiding everything, before.
Right. Yeah.
So I said, well, release the schematics, release the, spec sheet, everything. So the manual was very thick, heavy. Actually, it was heavier than the actual machine, probably, But that's the way, and everybody said, no, don't do that. But I said, no, because this is a very versatile, universal computers. So if we don't tell people how to use it and how can it be used, we won't be able to sell. That's why I said release everything, and that's what we did. So including schematics, we released. So that's why we got so many aftermarket stuff, add-ons and this, that, and whatnot, because they didn't have to reverse engineer anything. They just just look at it and they can make anything. So that's what we did.
Yeah, I'm trying to remember who it was at Commodore that I was talking to, but they had lots of feedback from customers about how great it was to have all of this information available on the VIC-20. So they decided to do that and as much more as they could for the Commodore 64. So, thank you.
Thank you. You're welcome.
God, I really appreciate that too. Thank you. I think time has shown that more documentation is better than less. It's just, especially with a computing platform. So I hate to move on from the Commodore 64, incredible success that it was, but we've still got a few computers left to go here, including some esoteric versions of the CBM machines that I don't know much about. And I'm curious what you folks can enlighten us on these. The 500 series, the 600, the 700 series. Apparently, they used a different CPU. Is this the first time?
6809, those
The
kind of things?
6509?
6509.
Yeah.
I thought he stuck it. Go ahead.
It was really a 6502 microprocessor, but it had bank control bits for the upper memory bank itself. And we actually wrote software then to bank in 32K, the upper 32K at a time, to be able to take the upper memory and bank it in there at one time and not. And I remember writing those banking routines to allow for the additional banking. That's pretty much what it was. It was just a lower port that it was in zero-page memory that had the upper address bits for the upper 32K.
There were some that were dual processor because they had like a transistor right in series with power, and I thought that second one was Motorola Ticket.
The Super PET.
Oh, so the dual processor things, I did work on that a bit. I worked on a lot of the esoteric pieces within Commodore. I was the guy who did all the little oddball little projects. But one of them was actually even a CPM board in that machine, where we'd take a Z80 and we would share the memory bus with it. And I actually did the small BIOS within the Z80 side to say to get a character, they actually call across to the 6502 BIOS to get the character. And basically we ran CPM on those machines as well.
And there was a CPM cartridge for the Commodore 64.
And there was a CPM cartridge
as well.
for the Commodore
So,
64 as well.
That stupid cartridge.
yeah.
I've got the loud one now. Here, give me number 4. Here you go. Now, give that one to Yosh. He needs all the amplification. So the CPM cartridge doesn't work. All right. Nobody wants to hear this again, but we had this cartridge, and I found the schematic it came from. It was in the engineer we used to call Shooting Stars drawer, who came through in a flash telling us how we're doing everything wrong, but he did the Z80 cartridge, and it was a Microsoft board he copied to fit in the Apple II. And I looked and, there's where, and so the CPM cartridge I had the memo still, where a huge chunk failed because of the brand of an LS-257 in it, so everybody goes, it's too slow. Everybody jumps to its conclusion, huge memos. And we were getting fallouts of 20 to 40% based on which revision of the VIC chip you had in your CPM, in your Commodore 64. Well, the problem was when you plug one of these things in a 128, it just doesn't work at all. And so now I own the problem. And that's one of the reasons the C128 ended up with the Z80 built into the board was, one, I didn't want a half an amp of supply for a cartridge that might get plugged in. But two, it didn't work. I had to figure out a way, and it was, second OS, second processor ended up saving my life when other things like Magic Voice cartridges happened. But in doing so, we figured out what was wrong with the CPM cartridges. And that is, the way Z80 is, it goes, I'm going to do this, and I want memory now, and I want to do it, memory now, and I'm going to, 6502 in the VIC bus goes, it's your time, it's my time, it's your time, it's my time to get to memory. VIC needs memory when he gets it. So what they would do is go clock, wait to the Z80. So he would think he's getting it every time he wants. The problem was, if you halted it on the exact right instruction, he'd wait, but he would put it 1.2 volts out on the bus. And the LS-257s would oscillate depending on what brand it was. So it had nothing to do with timing. It's just you can't stop it then. So what we did in the Z80, in the C128, is Palea put in a little bit of logic, said, and if it's that one, let it go one more clock. Okay. So yeah, and so I answered this year-long thing and Frank Hughes was involved, but nobody had looked at the timing. They just assumed because of the brand it was timing.
Yeah, I just need the software on that
Yeah.
one.
I like CPM.
So the 6509 was, how does that relate to the 6510 and the 8510 and the, was there a 7510 in the TED machines? Is that...
7510. I was looking at Benny for the... So the 7510 is, yes, it's HMOS1. We were starting to do shrinkages, so I think we're getting down to 1.4, 1.2 rules. And it simply has a signal to allow me to control where the bus is enabled or not, and it latched the read-write line because DRAMs work at a different point in time than the 6502 did. So it's almost like 12 flip-flops difference. So, not much.
I see. So, but the 6509 must have had some more advanced banking because you had 256K machines on an 8-bit.
Register. It was just a banking register.
I thought there was an indirect comma Y where you could also push it to the other bank so it'd be there when you got there, but only one page worth.
Yeah, one of the instructions was the indirect comma Y that would access another bank based on another register.
Exactly.
So you had either paging in 32K or the indirect comma Y to use a different register to swap between those two.
Yeah, there's
It's a
a
very simple extension of the O2.
Which I used to say was like throwing one page's worth of baggage over the wall and then running over there and catching it. Yeah.
Yeah, it turned out the way Microsoft Basic worked, all basic fetches of data used that particular kind of instruction.
Okay.
So you could make Basic work without changing the software in any way by just making it bank off of that.
So the last time I heard Chuck talk about BASIC and Bill Gates was they bought the BASIC for cheap. And he said that Bill thought it wouldn't run well. And what Chuck said, he forgot it's an interpretive language that we could run with just a one-page stack because it's not like C, it's not a compiled language. And so the BASIC worked fine on the O2, and his words were, and Bill Gates forgot it's an interpretive language. Oh, but that'd be.
I think Chuck may have been underestimating Bill Gates.
I was going to say through Chuck's eyes, but
I have a question. How are we doing on time?
what's up to these guys? You get tired of hearing us just throw stuff. It's what time is it? It's 4:30.
Oh, 4:30.
Yep.
All right. Well, I think we've got an hour and a half here, so maybe we ought to kind of cherry pick what we got left.
Or do you want to do questions?
Let's talk just briefly about the TED machines before we go on to audience Q&A. And I've also got a little bit of Q&A from a gentleman named Brian Bagnell, who wrote the history book on Commodore. And we can kick in on some of those. But Bill, you mentioned you came in, the TED was already in progress. Part of your role was finish it up.
Make it work.
Yeah, tell us a bit about that.
Well, I remember the day Schroz opened up his Commodore sliding vertical cabinet and pulled out a Sinclair and said, "This is what we're going after." And then I realized when I did the Commodore movie, that's it. He felt he had done the Commodore 60 or the Apple killer, and now was doing
One of those?
yeah, except it was the C116, the one that's got the little chiclet keyboards and stuff. And what it was is Jack had done his Apple killer. He felt the C64 had won the war, and now he was kind of ragged that Sir Clive Sinclair had this space of his own over in England doing these $49 business computers for whatever, and they were chiclet based. So that's what he first showed me. And the color Spectrum, it's called Spectrum, right? Had just come out. So we were going to do the color version of it, and this thing is based. This thing's like today's Raspberry Pi. The C116, if you saw it. It's as close to a single chip board as we'd ever gotten to do. So single chip had sound, it had the DRAM control, character ROM was still external, but it had lots of RAM inside and stuff. And so it had been designed almost by the chip designers, because they made the core and then somebody had made the stuff around it. And so I get there, and I'm from an industrial design background, and I look, and there's problems with like the reset circuit's not going to work, and the millions we want to build it and stuff. But there was this decree. Schroz, my boss, would go to the mountain and talk to Jack Tramiel and then come back down the mountain with decrees. And one decree is it shall only have 9 chips in it. And I looked at this thing, and I said, we have to put a different reset in here or it's not going to work. And I added a chip, and they're going to go, oh, you're going to get fired. I'm like, but we need the chip. We need a good reset circuit. Well, it turns out I didn't get fired. I don't even know that Jack said the word 9. He would have said something minimal, cheapest, right? And yet I was the one that stuck my neck out for it. And so it was a system of computers. There was this little one, this medium one, a big one that talked. We stole the Dr. Richard Wiggins from TI Speak and Spell. We had John Fagans did the Magic Desk, so now we've got a Windows desk motif. And we had printers that were from the series. We had monitors, 1802 monitors. What it was a whole thought-out system for stealing Clive Sinclair's lunch, right? And it was supposed to be business. If you wanted a game machine, go get a Commodore 64. Do not compete with yourself. I mean, Mr. Trammell understood that, in my opinion, right? And so this thing didn't have sprites, but it had 121 colors, and it was called TED because it means TED, text display. It's for businesses. So this thing cost $79. That's what it was supposed to cost. I'd have bought one for that. If you were doing the business, remember I said to the guy, I run my business on a 64, and I said, run away. Well, I would tell him to use one of these. So it was well thought out concept, but then Jack Trammell leaves the company, and this thing dies on the vine. Okay? There's no marketing vision. There's no management vision. I watched the managers trying to chew on each other's legs and stuff. It was just horrible. And so what came out of it is they canceled the talking thing because they probably don't understand it. The little chiclet thing looks cheap, but yeah, that's called market entry, right? And in the 264 morphed into something called the Plus 4. Now, it's still my name on the drawings, but I wasn't the one that said, hey, let's put some moderate to software at best in it and raise the price $200. It's not what it was designed to do. So I did sneak in a UART or something since the price could go up. So this thing really suffered from, I'm from the group, Benny, you might be from the group, Yash, you're from the group, at least for a while, that had worked for Jack Trammell and then the next when Jack Trammell's gone. So I'm from that era where I could see the difference the lack of management made. And that difference is we got the Plus 4, which at $349 isn't worth buying. It's at 121 colors. Hey, by the way, anybody know why there's 121 colors instead of 128? Right. 8 shades of black is still black. So 121 colors. So, and yet it's still an example of what Commodore could do because if you look, it's a chip with stuff around it, right? So, and unfortunately that's kind of, and in doing so, when the one thing was that when we went to a CES show and we had announced the TED, and I was a young kid at the time, still bright-eyed, a woman showed me software she had taken a year to write. It was educational software, and I remember it. This little fuzzy thing would go down a tube, answer a question, and do a happy dance when it got the math question right, and would do something else. She said, "That won't run on your machine." And I'm like, "What? A year of my life." And so when I did the 128 then, somebody said, "Well, why did you put in compatibility? What was kind of the inspiration? Why go to all that trouble?" And part of my answer was to give back to those people that had given to us and supported the 64 and whatnot. Our last 8-bit gift was, here, this will work with the software you wrote. Feel free to use the 128 mode, but we're not screwing you on this one if we can help it. So that's kind of TED in a nutshell. Leonard, any of that sound right or wrong, just knowing your father? See,
And also, you hit the story on the Commodore 128 that I was hoping you'd talk about, which is that aha moment when that independent software person said to you, I wrote software, I invested some of my life in this. Now you have a machine that I can't carry that investment forward, so you made a Commodore 128 that allowed people to carry that investment forward.
And I won't say that was the only reason, but you need several banners when you're trying to think of what to do and how to bring this together. Mm-hmm. Now the 128 happened. But the one we're not talking about is the Commodore LCD machine. And so I'll hit that real quick because that's what I was working on after TED. We owned our own LCD company, Eagle Picture, the only LCD company in the States here. And I mean, that's us, man, leverage chip building and everything. So we were going to make, and I've got one of 3. It's beautiful. Mitsumi did a keyboard that looks real long throw, and it's really textured, yet it's flat. And the case opens up. It beat the heck out of the Radio Shack LCD bricks of the day. And so I had started on that. We were putting a built-in modem. We hired a guy from Bell Labs named Jeff Porter, went on to become R&D manager, director. And it was going to be evolutionary, right? It was the next thing. So Jeff is so good at what he's doing, and meanwhile, they had a P128 or a B128 or something that was being D1. It was called a D128. And I ended up working on that. And I threw away all the design that was sitting there. It wasn't even a VIC chip. I don't even think it was I don't know what I used for a processor. And I think I had a SID chip on it. That's about the only thing. So we threw it out, and this is Fred Bowen and me, during a week when we didn't let management talk to us, and we came up with the concept of, well, let's do a 64 capable device, but that means we have to start with the VIC-2 chip and stuff. That's the only way to get to that. You can't make a new chip to do it. And so we don't tell management till we got it almost working, right? And then we tell management it's called the C128 now, and you should see them run down the hall. I'm calling it the C128, you know. So we stayed ahead of their ability to stop us, is what we were doing, and making it seem like their idea all at the same time. And when they found out a Z80 had been built into it, it was too late to take it out. I was already using it for things, and so the C128 happened because nobody stopped us. Because nobody got in front of us and told us no. So it was really one of those rare instances where 4 guys got together, 5 including chip designer, and just made a product. This came off of a piece of paper on my desk, and we just ran with it because we worked at Commodore, the best computer making company in the world, with our own chip fab. So that's what the 128 was. Now, it wasn't meant to be anything big. It was meant to get us to a CES.
Oh, amen.
The Amiga was coming. The 16-bit era is upon us. And as I describe it, you know, it's like, well, let's shove everything we can in here now. By the way, we never said 100% compatible. Marketing said that, so we said, okay, we'll try. And we got pretty close. But we shoved as many things in there. I mean, we've got a Z80 in there. We've got the ROM monitor built in there. We've got a whole new BASIC that knows how to do sprites. The one thing we wouldn't do is water down the definition of the C64. They said, why didn't you make a super C64 version? Well, that's not any way to show appreciation to that market, because now you've made 2 versions of 64s again, which we said the purity of the 64 helped its software base. So I lost my train of thought there because I get excited about this kind of thing. But so at the end of the day, we shoved as many things in, CPM, you know, all those things in there. And I call it 9 pounds of poop in a 5-pound bag because I couldn't get 10 pounds to fit. Right? And it was kind of, we knew the 8-bit era was ending, so we knew we were going to be turning the lights off on this, so we shoved as much crap in there for you as we could, going, you figure out what to do with it. And people say, well, does it bother you? The CPM didn't get used a lot. No. My job, put it in there. Your job, figure it out if you want to use it. And then I'd get other people to say how they would run home at lunch to do Turbo Pascal under CPM because it was so much faster than the computers at school. So it depends who you talk to and stuff. So, but we had no misconceptions that it's evolutionary. No, it's just it's a big thing to put a monitor on.
And I guess that plan must have worked because you sold about 6 million of them.
Yeah, more than the Apple II, I'm told. But you know, I'm in California
the
now,
Apple
so I have to
II,
watch.
all models combined, I think, are about 5.5,
5.7. I think we did 5.7.
million.
It's the number I use.
Yep.
For the 128.
Perfect. Now, before we go to audience questions, I'd like to ask Benny a question about the machines that aren't up on the board there. There is actually a website, if people are interested to go to, called The Secret Weapons of Commodore, where you can read about lots of machines that never made it out of the Commodore R&D labs. I'm just curious if you could tell us about maybe 1 or 2 machines that we don't see up on the board but could have.
Oh, absolutely. I'm the guy. I started out, like I said, in the cash register group. That was canceled within a year. They moved me up to help finish up the Commodore 64 and the B-Series machines and peripherals. And mostly was doing disk drives as my main project for teams and designing disk drive circuits. But I also became like a little pet of Shiraz, who would send me out on every month or every week or 2, he'd come up with a new project to go out and look at some new company, say an optical disc or a CD-ROM or this, interface this to the device and some whiz-bang thing, and go out and investigate some company. And eventually Shiraz made this R&D team. After the Commodore 64 was successful, he had enough money to split off of the main engineering, where he had like 5 of us guys together. And he just basically would just give us a Post-it note when we walked in on Monday morning, go build one of these for me. And after about a year or 2 of doing this with him, and I sat down for my formal review with him, I was like, Shiraz, I built all these things for you, but you never let me produce any of them. What's up with that? Because I just like the way you start things. You had all these fun toys I would build for him, but we never really finished them. However, one of my last projects that we went out to go buy was a little thing called Amiga. And that was the last thing I bought and integrated into the company. And that was a little something, I think.
Which could have been a big something if they had the right management still working there.
It was actually the next generation Commodore 64 is what we had that we had picked that technology up should have been for.
It was actually the next generation Atari machines.
It really
Because
was.
the people that designed the Amiga were the people that designed the Atari 8-bit machines.
Yeah, we snuck in and we bought the design from people who worked at Atari.
Leonard there went on to become the vice president of software at Atari during the Amiga time.
Where?
Atari.
Oh yeah, I heard of that.
Yeah, okay, that one.
Benny had the kiss of death. That's what he's telling you. He'd start these projects and not be allowed to finish them. And he told me he has the kiss of death. And so when he would walk in the office, we'd throw ourselves on the schematics so he couldn't look at them or touch them or anything.
Yeah, it was
So we, in fact, don't know how many great machines we could have had from Commodore.
like I said, I could be 1 week, 2 weeks, or a month into a new machine, and then I'd get a new assignment. And that was pretty much how it went for 3 years.
Were you part of picking the LCD machine and that initial config that came from North, I think the guy's name was?
No, I didn't. Not on that one. But
Well, why don't we take some audience questions, and I'm going to intersperse them with some questions that we have from the Commodore history author that I mentioned, Brian Bagnell. But let's start with an audience question. If you've got a question, could you raise your hand and we'll get you a microphone? Anyone?
Come on, you know you do.
Someone
you
must
guys
have
have
a question.
questions.
Explain about the cereal bus or something.
While you guys think of those, I'm going to bring up the questions we have from the outside.
Yeah, I have a question for Leonard. A lot has been written and said about how the Xerox PARC inspired the Apple graphic user interface for the Lisas.
I'm having trouble hearing.
Yeah. Yeah, a lot has been said about how the Xerox PARC inspired the graphic user interface for the Apple Lisa and the Macintosh. And my question is, what inspired the text user interface of the Commodore PET? I find it very distinct and very beautiful to have no prompt, to be able to move the cursor freely.
So a little appreciated feature of all of the Commodore 8-bit machines was what we called a live on-screen editor, where you could just cursor your way up to something and type it and go. That was all Chuck's idea. Wow. Yeah,
Good.
Chuck said, the data's there, use it.
And John Fagans wrote that.
And John Fagans wrote that code.
Yeah. And if you remember VAX editors, there was the EDI editor, which was line-based, and an EDT editor where you can move around. And my first day when I went to Commodore to interview, somebody scrolled up, changed the number, and hit return, and I went, I want to work here.
Yeah, the ability to do that was really quite remarkable. You could have programs that would list themselves and then go up and edit themselves, which was interesting.
Yeah, true. It's very distinct and beautiful.
Yeah. That's one of the features that I wish had propagated through, and it doesn't exist anywhere. Someone write it, please.
So I have a question for you, Yash, from Brian. The question is, there was a period in the early 86, just prior to you leaving Commodore, when you proposed a cost-reduced Amiga around the same time Jeff Porter was proposing one. Can you tell us anything you remember about that, including your ideas for what that might have been?
Well, actually, I don't remember that. But what I can tell is, as design engineer, what we do is we design one machine. The next phase, right after that, is to cost reduction. You always think about that. How can you make this one better, faster, cheaper? So that's rather than designing a new computer, we always redesign the computers to be better, faster, and cheaper. So probably that's one of the thing I was doing it. But I don't remember because I quit right after that.
And there were a variety of those that came out, right? Like there was a Commodore.
Cost reduce thing?
There was a Commodore 128D cost reduced.
Oh, Well, the one I'd say first is the C64 cost reduced, which was Katayama-san,
E-type,
right?
yeah, we
But then
did the E-types,
Sam
yeah.
would have been like the office, the impetus behind that, I'm guessing. And he basically went out and found hybrid chips. And I believe one of the biggest cost savings is just in the square area of the PC board. Turns out at our quantities, that's not insignificant to cut the PC board in half, which is what we did. The C128D was supposed to come out at the exact, which has a built-in floppy. It's got a keyboard that clips up under it, a place to wind your cable, and it's got a built-in floppy, as I said. And it was my favorite. It is what the C128 was supposed to be. It's this thing right here. And it was supposed to come out on day one, and it literally almost made us late to make the PC board fit both and do both things. Recessed reset switches, internal I/O connectors to the floppy drive and everything. And regardless of what they say, it passed FCC at the same time as the C128 did. I leave not long after it comes out, and only later do I find out they never did the 128D the way it was supposed to be done in the plastic case. We call it the real 128. So I was given one of the things, somebody said it failed FCC. Well, the answer is they didn't have enough money to release a second model at that time, is my understanding. So then later I hear about this D, which I've heard called the Black Diesel. And the screen looks like a Black Diesel. I mean, it's all noisy and stuff. I mean, to an engineer's eyes. I look at it, and then the grounding sucks. And it gets into the video and everything. So while that's most of my design in there, I see where it looks like Germany or Tokyo went in there and took out the parts they didn't like and changed it, but they disobeyed a lot of the tenets that we tried to design for video cleanliness and stuff. And it's big and clunky and metal and so.
You did like it?
Black Diesel.
Do we have another audience question? Gentleman back there? Could someone pass?
What was it? Wrong direction, right?
Yeah, sort of.
Somebody fill in.
I don't understand the question.
Why did we come to Santa Clara from we're a Pennsylvania company?
Why did who come to Santa Clara when?
Back in the 80s or 70s, you mean, right?
Who?
They started.
Commodore started here.
That's why we're confused.
Yeah, so I'm not sure what you mean. So the Commodore, excuse me? What about Lancaster? Okay, so MOS technology was purchased by Commodore in 1975. At that time, Commodore was out here in California. So they didn't move from Pennsylvania to here. We were here.
And MOS is in what we used to call Silicon Valley East. There were 5 or 6 chip plants up into SSI and ICS and stuff. So we were in an area, I mean, MOS is there because they made chips around that area. Now, I had heard that they moved to Westchester because engineers were cheaper, and you said, you shot me down as an urban legend. I thought you said that. So I heard that one of the reasons they moved out there was, yeah, you did, because your answer was,
so I know that there was some issue with cost of living.
right.
So the question of there had always been for I think all the way through that time period there were still people
Still
out
was
here.
at Santa Clara.
So it was always out here. And then the question was, where do you build?
And Leonard's answer to me not long ago had been, no, it was because MOS was there. That's why we moved there. So that made actually more sense than engineers are cheaper because.
Yeah, I mean
Now I got paid $24,000 a year. I made the 128, so we were kind of cheap.
Yeah, So I was confused by your question.
Yeah.
We did nothing moved from there to here. It was something there that got purchased.
And it did build up in the MOS facility. There was like a reconcentration of engineers at the MOS facility. There was the few that came out from California. They moved us up from Dallas.
Yep.
And it was really kind of a magical place. It was one of the most wonderful places I ever worked because there was chip engineers in there. There were people who understood basic interpreters and languages and operating systems. And everyone was there in that room on top of that fab. And everybody was just really, yeah, like I said, a magical place. Totally vertically integrated.
I'm supposed to be here.
Get all-
No, I'm supposed to be here to help run mics. So if anyone else has questions, you want to start in the front and you pass it behind you when you're done?
So they built the SX64, which I still consider one of my favorite Commodore computers. But you never made another portable. Was the sales of the SX64 the reason, or was there no interest, or was there interest but you figured it would cost too much? Why was there never another portable?
I don't know the sales numbers or anything. I mean, it was our favorite thing too.
Oh,
He's saying he has one. He was waving at me. I'm not going to try and open it. I'll break it. Well,
I thought I had the last one of those. That was one of my favorite machines also.
I've still got mine.
Yeah, you got yours? Okay.
Yeah.
So I worked
Got
for
a
an
great
Amiga
low monitor.
dealership, and this was around the time Harry Copperman was the president, and my boss was trying to tell Commodore they needed to come out with a portable. And nobody would listen to him. And like this, because of its being portable, is probably one of my favorite machines.
yeah. No, we loved it. We coveted them. It was a little hard to play games, because the screen is smaller. But and my understanding is, I would have thought. Whoop, we lost Josh here. Maybe he's talking to Chuck. Might be talking to Chuck. So my belief is they worked with Mitsumi and maybe JVC or somebody to do the case, and this would have been done in Japan. And some of those things happen, like C16s and things. They get done over there, and we come over and find out if there's a market or not. But I assumed it was the cost. What was the cost back then? Do you know?
$1,000?
Yeah. It costs like an Apple costs, and we already had carved out this other space,
They weren't cheap then, and they're not cheap.
No.
That's what I thought, 1,000.
Yeah, you can buy like 3 or 4 of the regular ones. Actually, that includes a floppy, though, so that's... Yeah, that's a sweet machine.
Is there another question?
Yeah, I had a quick question. What was the thought behind selling the 6502 to competitors like Apple after Commodore bought MOS? Wouldn't it be less advantageous?
Who? Apple?
Oh, there he is.
Apple wasn't a competitor. Apple didn't exist. I mean, it literally did not exist.
Okay.
And when, at one point, one of the Steves, I think maybe both, came in to talk to my father and said, we're going to be using your microprocessor to make a computer. Do you want to sell it? And Dad said, no, we're making our own. But thanks for using our microprocessor. Here's some more free samples.
Now, at the anniversary, your dad talked about the possibility of buying Apple. And he offered $15K, and Steve Jobs wanted $45K. And so they did not agree to purchase Apple.
Yeah, that would have been an unusually good deal even for my dad, who was good at good deals. Yeah, getting Apple for $15,000, that would have been good.
And the other one was they wanted $1 each for the copies of BASIC. And your dad's response was,
I'm already married.
I'm already married. Yeah. So he's like one of the few people just paid a blanket cost for BASIC and walked away.
Yep.
Just related to that, the 6502 you sold it to Atari. So what was the thinking behind that?
Couldn't hear you.
Sorry, the 6502 you also sold to Atari for many of their games. So similar to Apple. I'm just kind of curious, was it a similar kind of, here's some more samples, but then somehow Atari ended up getting a lot more?
There wasn't anything else you could use. The 6502 was the only microprocessor available at the time that had the power and the price.
And it was also licensed through Cinertech and Rockwell, and so you could get it from multiple vendors too.
Yeah.
So,
So the 6502 was just barely existing when the Atari VCS came out. So that predated Commodore's involvement with MOS technology. So you want to buy more stuff? Great. That's fine. Yeah, the number of things that use the 6502 was remarkable. So all of the Commodore 8-bit machines, all of the Apple 8-bit machines, all of the Atari 8-bit machines, the Nintendo Entertainment System, and a bunch of other products, some of which are here, were all based on the 6502.
so if I could jump in then, if you've seen the Terminator movie, that's based on the 6502, if you look at the code. And also Bender from Futurama. And so I did an interview with a video interview with Chuck years ago, and we showed a clip, and I showed the Terminator, don't in the code, and then Bender doing kill all humans with the 6502. And I asked, I said, are you really an evil genius bent on destruction of the world or what? And he didn't miss a beat. He goes, no, if you look at the number of life-saving devices and medical equipment and, I said, so you're coming out ahead on the curve of destroying us versus like actually, and he, yes. So, yeah. Now, as you may know, I'm part of this video, Junk Food, and we just did Easy to Learn, Hard to Master, and we actually showed it here a month ago. And we talked about how the Atari guys said, look, we need to go this fast, and it's going just fast enough to like load the line buffer. Because in the 2600, you have just like a line ahead of you where you have to keep stuffing stuff in there. And they figured out the 6502 could do the job. So it was the right process at the right time. It's not to say there weren't Z80s and stuff, but the 02 is the best.
Yeah, so following on the question about the sourcing the 6502 to Apple and Atari, my understanding is that happened because Cinertech became a second source for the 6502, and Atari and Apple actually bought from Cinertech. Why did your father decide to, since he had a captive microprocessor, to go for a second source of having Cinertech do it? And I have a correction later after this.
I think it was just a question of having enough production volume.
Okay, so Cinertech. Okay,
We kept MOS plenty busy ourselves.
one minor correction. You said the Amiga was a follow-on of Atari, but just to correct that, when the predecessor product before Jay Miner and I invented the Amiga was the clock chip for the Macintosh. So I think it is correct to say that the Amiga
it's not the only follow-on.
It's not the only follow-on of Atari, but also Apple.
So
there's a triangle connection there.
So Jay Miner's fingerprints in the design philosophy of a video computer system are obvious in the 400 and 800 and in the Amiga. It's clear that the same person was designing both machines. And it's all, and the similarity in, again, hardware design, especially the way video and memory interfaced between the Commodore 64 and the ST is the same. Yeah, no. So it was the video between the Apple, the 400, 800, and the Amiga is the same. So you're saying the memory for the Amiga came from the Apple.
Also, with
The
respect to
NTSC
the
timing? Wait a minute. You're talking about feeding the video display controller from DRAM in lockstep with NTSC timing, right? That comes from NTSC. That comes from, so we had to make the DRAMs get the row and column addresses out so our time slide, and the VIC-20 did not do shared bus, but every Commodore product since then did, and that was the VIC chip that allowed it. So it's, it'd be like saying I invented water. Well, it's because it's useful.
Well, that was Jay's insistence. Everything must be driven by the video.
Yep.
So the sourcing, I read something about this in preparation for the panel. Chuck Peddle had mentioned that with respect to having alternative sources for the 6502 that in the semiconductor world, people would be reluctant to buy from you if there was just one source for a product because they realized that could impact the supply chain. So,
Oh yeah, it's like Hitchhiker's Guide to the Galaxy. If you got two sources, it's like having your towel. It means you've got distribution. Military people must be using it if it's Rockwell. Because the company I worked at before there used the O2, which is how I knew so much and got in the door. And we didn't look at it so much as MOS as a Rockwell or a Centertech or a MOS. So it added horribly to its.
Yeah, so you got to remember so Chuck's vision for the 6502 was that this would be a popular enough microprocessor that it would be in everything. And in order to get standard semiconductor people to want to use this chip, it had to be second sourced.
Hi, the discussion of the unparalleled popularity of the 6502 reminded me that the one thing missing from this discussion,
Chuck Peddle.
other than Chuck Peddle, is a discussion of the SID chip, which was also used on products outside of Commodore products for devices such as other devices for electronic musicians.
SIDs were cool.
Yeah.
They made pretty sounds.
They had a 3 dB per octave filter, but you couldn't get a programmable filter hardly any other way. And Bob Yanis, who I found out is a fellow Emerson, Lake and Palmer fan, and I often told people without Emerson, Lake and Palmer, it wouldn't have been a 128 either. And of course, that's now doubly true because there might not have been a SID chip. And his design philosophy, as Andy Finkel told me once, was one clock to clock them all and one clock to bind them, And so he had this whole philosophy of just what you said, the video display drives the timing as a J minor. And Yanis had this thing that everything that happens needs to be synchronized back to, and he's absolutely right. That we found out more and more later that's it. So he that was quite a chip. And they're a little noisy and stuff, but it's what else are you going to use? People did turn that to advantage. They made white noise part of the music, So. Oh, I could sit and listen to the theme of Mule all day long, just.
other questions? I think I've got a couple more here from
Brian?
Brian Bagnell, and then I guess we'll wrap up. Let me bring this up.
By the way, anybody ever listen to the theme from Mindwalker on the Amiga? You leave that on for 3 hours, your brains are dripping out of your ears. It's just...
Amiga?
Yeah. Well, that's after we bought Amiga. You walked down our hall, and you heard the same theme music coming out from every... And you thought you'd walk in and see us with brain parasites or something, because they're all just...
Benny, Brian had a question for you. He says, my understanding is that Jack Tramiel wanted CBM to compete with IBM, and that's why they got into the cash register business. Can you tell us about the origins of the cash register products and what finally led to Commodore pulling out of that market? And Leonard, you might have, looks like you've got a thought on that as well.
So on the cash register project, we took a PET and we put cash drawers on it and cash register keyboard and printers and networked them together and so on and so forth. We were very successful in selling thousands of PETs in a very short period of time. So Commodore picked this up, productized it, and built a real cash register in Dallas within a year. And we started getting orders for them. And Jack found out that the cash register, when it gets sent and sold to any city, you need to have a cash register dealer in that city that gets a piece of that money. And because if someone pours a beer in that cash register at 1 in the morning, someone needs to get the phone call to come replace it and fix it out. And this is something he did not want to do. It was basically a business decision that he did not want to be in have a service contract, a piece of the profits of his device as part of the service contract, and basically then he sold it to TEC and dissolved that team. As far as competing IBM, we did have an IBM compatible chipset that we almost produced for a while, and we put it on the shelf for a bit, and then finally did
Kiss
produce
of
it.
death, yes.
Yeah, okay. But we also had a Unix machine that we had for business market. But whenever we ran into the severe competition with our pals at Atari, and we ran into the banking problems, they cut half the staff at Commodore and cut all the business machines as far as the IBM PC compatible and the Unix machine. And then they took the Amiga and tried to sell it to the business market. And that was how that really kind of boiled down to.
So, and one of Jack's business beliefs was that you make the machine for as cheap as you can and you sell it for as cheap as you should. You don't try and make a lot of money off it. And so that to him meant the distributors shouldn't get a lot of that money. They can make the money off the software. Knock yourselves out on the software. But, you know, this hardware, we made it as cheap as we can, and you're not to get a piece of that. He didn't like that piece going somewhere. Correct me if I'm wrong, Leonard, but
that was exactly the philosophy of closing down.
That was the business model.
yeah,
That was the business model for the Commodore 64. It was the standard, although I know nothing about it, the blade and razor business.
Other audience questions? Well, all right.
everything about Commodore.
So everyone has never wondered about anything related to this. You've had all your questions answered. That's great.
This is a banner
Mr.
day.
God.
Got one.
Oh, we might have a question. Oh, another one over here.
For both chip design and board design, what did you use any interesting tools, or was it all hand drawn?
I'm sorry.
It was talking about the design tools. Very early on, in fact, I brought something here to donate to the museum. The original 6502 was done with pencil and paper. And I brought a copy of that schematic here for the museum that I happen to have in my drawer that I found in my attic. That you can see what happened there. It really was pencil and paper for drawing the 6502 schematic.
And then Rubylith to make the mask.
Yeah, then they put Rubylith on top of it to build the individual mask, and then just shrunk those
Climb
pictures
up on
down.
the tables, kick their shoes off, and get up there with razor blades and cut Rubylith, which is a red material, that then they would reduce photographically. It wasn't done electronically. Eventually it became a tape, I think. And so talk about handcrafted. It really was. And one day I was talking with Benny, and I said something, and he said, oh, 6502 schematic, follow me. And I follow him into the Calma area, which is what we called once we got some CAD. And we said it to Michael Angelina, who ran Calma, and he said, 6502, oh, I got that. And I'm like, what do you mean you got that? And he takes us to the darkest corner of the whole place, to the bottom drawer of a dusty cabinet, and he opens it. Right? And as this happens, there's chanting starts, there's a fog, there's incense burning, people, and it's a religious experience for me, right? And he pulls out this thing. It was written on parchment. I mean, this thing is like and I got goosebumps talking about it. And then Benny here looks down and he looks at a pin and laughs. He goes, because CPS pin it was called, and he Chuck Peddle Special. They had named a pin after him because Chuck really wanted that thing. And that was actually the first thing I ever said to Chuck when I talked with him.
Which is the set overflow pin. They
Yeah.
set the overflow bit.
Set overflow pin was the Chuck. But I remember the day I saw that schematic, and I'm like, talk about working at a priesthood,
But it started like that. It was done by pencil and paper. Yep. And then eventually turned...
So with the C-128 was done on graph paper, but it was the last one. Dave Haney, who worked for me, converted it to Mentors. We had started to use Mentors in the Z8000.
Right, the Mentors.
Yeah, and we got in there. But this is like 83, 84, and it was almost a second entry. We'd gotten it working from the paper, and they still would take them over to the drafts girl, Sue, who would draft it. And what's funny, she ended up at Ensoniq, which is where Bob Yanis, the SID chip guy, ended, and she made the schematic look exactly like a C64. She would run the pins behind things, and where the SID went was their voice DMA fetcher. I mean, it looked just like a C64, so you could recognize her style. So we ended up then getting into the Mentors about that time. We did not have electric rule checks, and we had design rule checks when we did a chip. So when we did the TED chip, which is in the TED series, they were on Rev 3 and it still wasn't working yet. So I was in the upstairs chip lab at MOS, and what had happened was they had these address lines running like this, and if an address line ran too close to another one, the DRC, design rule check, would go, oh, it's too close. But they didn't have an electric rule check that said if you run right across and short them all out, nothing would catch that. So, and it did. They all went like this in a corner, except one went like that and cut the corner twice, right? So what it meant was they couldn't talk to the registers in the TED to turn it into, it starts up in PAL mode because the timing has to start more relaxed, and then needed to be told to go into NTSC. Well, now they're on the third rev of the chip, because the errors didn't work, and they still hadn't tested NTSC mode. And they need to test this. These turns cost us $250,000 minimum per turn. So I'm in the lab, and the guy goes, okay, turn on the light. They're under the microscope, and they're probing. They get the chips made, and they actually drop little wires and wiggle them until they tear into the material, and then they put them up on the scope, and it's called rape and pillage. And he goes, okay, turn on the light. Okay, turn it off. We're in NTSC mode. Now I look, did you just use the photons of the light to flip the bit of a register? They go, yeah, I think I love you. I am so working in the right place.
Yeah.
And it was. I mean, I knew photons were real, you know? And there was our proof. And they were able to debug part of the... But we fought that for a long time, not having because we didn't have an electronic schematic, there was no electronic rule checker. And mostly came about as we got in later into the later CALMA, then there was everything, and then finally into the standard cells and stuff that we were doing in 86, 87. It's amazing it works, truly.
Yeah, Chuck told me that they had the mask layout, effectively, of the 6502 up on the wall of the room they were working in. And they had a rectangle. This is the size that this chip will be. And it had to fit in that. And they would hand draw it.
Tape and lay it out manually.
Yep.
And I was going to say...
If you see the schematic of the 6502 that was drawn by hand and the layout, it's one-in-one. It's pretty much one-in-one of the chip.
Wow.
It looks exactly like that on top of it. They put a transistor on top of the schematic
and so
physically by taping it on.
Right. And to show that that's not without errors, I was talking with the process engineers that make the chips, and on the 6502 they had laid a little LCD temperature sensor die on it, like a mood ring, right? Remember those things they would change to? And they laid that on the die, and they found a hot spot on the 6502. And they go in and look carefully, and they find what's the equivalent of a 200 ohm resistor between VCC and ground that just got in there. By the time you're cutting all this ruby lith and doing schematics, it just got in the design and had to be taken back out to how many 50 mils would we have cut by doing that or something. So, and that's cool when you work at a place where the process engineer can show you his mood ring. That's pretty cool. And then they blew up the grate full of chemicals. Yeah.
I think we have a question over here.
So one of Commodore's 8-bit computers' strengths was they control the full stack. They design the hardware, the chips. So before acquiring Amiga, did Commodore think of creating its own 16-bit computers with its own 16-bit chips?
Can't hear him. I can't hear you. The speakers are pointing that way, so.
Come on up. A processor?
Yeah. No.
No.
So instead of an Amiga.
Well, I thought the question was, would we have done a 16-bit processor rather than use the Motorola 68000? Am I wrong? If we hadn't gone with the Amiga?
Yeah.
We had a Z8000. Yeah.
There was a Z8000 based machine. The processor group at MOS Technology was working on a 65. The 600. So the other term they used, so it was the E4, was the 650,000. Yeah. So there's the 6800, which became the 68,000 when it went to 16 bits. So they wanted to go up one more. So this was the 650,000. And there were lots of interesting design specifications and computing techniques built in, but it never went anywhere. And as far as a video chip to go along with it, I don't know if there's anything there.
No, we didn't. And I'll add to that, the 68K came out in that big Hershey bar and stuff. I don't think we were tooled for that kind of carriers. And, I think MOS was reaching the end of its lifetime. And I only recently found out that one of the things about the later Amigas was they couldn't get the chips from NMOS anymore. They weren't fast enough. They weren't dense enough. They needed to be CMOS. Right. And so part of the reason the costs went way up on the Amigas was they kept having to go to outside fab and things to make that work. Now, there was a Z8000, and they were a source of constant amusement for us, the Z8000 group. We called them the Z guys or something, Z group. And one of the coolest things they ever did was they stole the furniture out of the lobby and stuck it in a cubicle, and we stopped teasing them for a week because we thought that was pretty cool too. But they worked for 2 or 3 years on the Z8000, and the Z8000 had claims that I don't know were that meaningful. For example, it used only 33% of the chips that a 68000 did. So it's supposed to be lighter, cooler, faster, all of this stuff. But at the end of the day, a product that goes on for 2.5 years at Commodore is already dead. It just doesn't know it yet. And so the Z8000 finally shrunk off and kind of died. Were you there when it died?
Yeah, it was. It was part of the reduction.
Oh, did you do the?
It was part of the reduction.
Yeah, the bullet behind the ear thing. Yeah. Oh, Z8000 wasn't the problem. It was our ability to make it into a computer and the DMA support and stuff like that for it. Yeah. Oh, we didn't make it. We bought them from Zilog.
It wasn't a custom chip. It was a processor from Zilog.
Yeah, it's 16-bit Z80. Yeah, exactly. Yeah. Go ahead. Making SIDs?
Were the VIC and SID internally designed based on your requirements, or were they bought from outside companies and then brought inside, or how did they come about?
The VIC and SID chips?
Yes.
They were Al Charpentier and Bob Yanis made kick-ass products.
So
they designed it from scratch with their ideas.
Yeah, see the movie Commodore Wars. They interview Charpentier and they talk about Yanis in there a lot, and that goes back to they were making a chip and needed to show it, and then that begat a computer, and then that computer begat a better chip that was the C64. And so, no, they sat down and did those. And, I've been quoted as saying about other computer competitors, they just used our chips because that was our mentality. We're the people making the really fancy, cool chips, and the other people couldn't do that. And it's because it was our designs. And hand-tailored somewhat to get them to work in our fab. We went round and round a couple times to get those things work, especially some of the analog circuitry is my understanding. It never really lived.
And the question was, by the way, why did Commodore not continue forward with the C65?
Paul Lasser, are you still here? There's Paul Lasser. He worked on the C65. I ran some theories by him. I asked him, well, how many prototypes did you make? And remember now, Amiga's been out for a while, but Commodore's been killing the products or not releasing them. They tried to do IBMs, and then they literally ate their own young again, but they would sell in Europe and look popular. And meanwhile, as they're looking to sell the company, they produce, hey, let's go back to the wonderful days of 8-bit, in my humble opinion. Sorry, Paul. But I'd say the effort went in that should have been an Amiga that cost that same amount. I mean, they're trying to take a slot away from what Amiga should have been, which is this, if you wanted a cheap little, it's a wonderful C65, the Amiga I'm talking about. So the question I asked Paul was, how many prototypes did you make? He said either 100 or 200. And that's the reason why y'all know about them, is because that's a lot of working prototypes with OS. The OS fully works and all that, Freddie Bowen, who did this 128 with me, he did that kernel. I'm sure it's great. I'm sure it's the best part of it. Sorry, Paul. But I asked Paul then, I said, well, I guess how many prototypes we did for the 128? And the answer is 3. And it's not 100 because we're on our way to getting a product out quick. So to me, the fact there are so many prototypes, it kind of shows that Commodore was probably in a holding action trying to keep the engineers busy and didn't have the money to actually release to production. And at this point, they're cash poor. Paul, did I get all that right without pissing you off? Yeah, come on up, man. He's a Commodore guy.
Yeah, we didn't. It wasn't as you say 3 prototypes. That's in terms of 3 revs of the motherboard before. Okay. Yeah. Okay. So we actually did a pilot run in our Hong Kong factory, and I don't recall whether the number was 100 or 200. So we had fully working systems, and it was about the same time that Commodore was deciding to release the Amiga 300 or 600, and the company did not have the financial resources to launch both products at the same time, and they went with the Amiga. Now, as to whether, your comment saying that you should really just make an Amiga for this price, that was looked at quite a bit, and technically speaking, you couldn't get the price of an Amiga down to the 200 price range. And the C65, we were able to hit that price point, and in the later time of working on it, we had built in, we supported most of the Amiga graphics modes, and we were able to put in some of the capabilities of the Amiga custom graphics blitter into it. So it was meant as an entry vehicle, a Commodore product to a customer base that had a cutoff of $200, would get them in the fold and left the Amiga as an upgrade path. And that it gave them a taste of the Amiga, and if you want to go from here, go up from here when you can afford to do so. That's about what I can say.
Well, thank you, because I wasn't there at the C65, so I've worked off Urban Legend, and I didn't know the things you just told me, so I'll change what I say.
Thank you.
Thank you. I'll ask.
All right, well, thank you very much. I'm going to end this on a little bit of a tribute. The machines that you see up there on this poster, to me, they represent an entire generation. People's careers were birthed out of what these machines represented. You guys unleashed your drive and your creativity, and you created these machines which allowed an entire generation to unleash its drive and creativity. It's an amplification effect that affected millions and millions of lives. And I think it's great. I'm very touched by it. And I want to thank you for that. And thank you for being on the panel today. And I'll include Chuck in absentia, who couldn't be here, in that tribute. But, from my heart, a heartfelt thank you.